record for that to happen.
Oh!
That wouldn't happen if you're on recording.
That's true. How those Packers do this weekend? Anyway.
Weaver's a good team, so.
Anyway, so as you look at this one, once again, the first thing you want to identify is where is the change occurring? Where's the change occurring at this problem? At -2. Very good. So I know that the change is occurring when x is -2. I'll move this over a little bit. And I know that I have two equations. You're going to see it every time I do that now, aren't you? It's so true. And you do the same thing. On the first graph that you're reading, it's one that has the positive slope. It's an open dot, so what do I know about that? Is that a less than or is it a greater than?
Less than.
It's less than. It's less than because we know we're pointing to the left. Okay? And then the other one is very good, greater than or equal to. Now it's a matter of walking your slope and identifying your y-intercept. Excuse me. In this problem, is it clear to you what your y-intercept will be, or do you need to just do a couple extra slope walks? Yeah, just a couple extra slope walks. Now, we start with a given point. Up one, right one. So I know my slope is how much?
1.
I know my slope is 1. And I know that I have a positive value for my y-intercept. My b value is positive
X minus 5.
And there's my equation. I'm taking what I have as far as the graph is in front of me, and I'm walking my slope to find the intercept. Okay? And then the other one is a horizontal line. And this is where some of you guys still mix up. Remember, all horizontal lines start the same way. Y equals some number. All vertical lines are x equals some number. And the horizontal lines go this way. Let's go that way. So that's a horizontal line. And what number does it go through? -2. And that's it. Right, Ms. Butler? I saw a scrunchy face. I want to make sure. Yes, sir.
Isn't that saying x equals -2?
No. It's saying the function is -2 when x is larger than -2. Remember, f of x is another fancy way of saying y equals.
Oh.
Okay? F of x is just another fancy way of saying y equals.
Okay.
Get it? All right. So I'll walk you through the next one, then I'm going to let you try the next two. Look, I have that one on here. Forgot to zip this one in. I'm going to do it this way. Sorry, I forgot to input this one
Put it to what?
into the smartboard, into the notes. Where is it? Oh, there
How
it is.
long did it take you to organize all this?
Not very, because every time I put something in, there's a folder, a place to go, and I just label the file. That's all. After a while, it's just an old hat. I mean, I know where everything goes. I know. And when I see people that don't have things in files and folders, I get the heebie-jeebies. I get the shakes. But that's fine. All right, so in this case here, how many graphs do we have? How many equations are we going to have? We have 3 of them. So we have to worry about where 3 things occur. The 3 values we have to worry about. I have something happening at -1 and +1, and something that happens between them. Everybody see that? So I know that something's happening when x is smaller than or equal to 1, and I know that because it's pointing to the left and it has a solid dot. Are we okay with that first graph? Then something happens to x when it is larger, that's missing -1, larger than -1, but smaller than +1. That's why there are the 2 open dots. Okay? And then lastly, something's happening when it's greater than or equal to 1. I know this because these are all assumed to be at 1 tick marks. That is a solid dot for the first equation. That first equation, solid dot, is at -1, and it's pointing to the left. So all values that are less than -1 for the domain are on that graph. All values that are between -1 and +1, not including them because of the open dots, are on the second graph. And then lastly, it drops back to everything larger than +1, including it because of the solid dot on the last bit. Okay? Now it's just a matter of identifying slopes, walking through to figure out what some of your intercepts might be, and labeling them out. So in the first equation, let's see, looks like we're going down 1, right 1, down 1, right 1. Appears is off just a hair, but I'm going to say that slope is 1. You guys agree?
Yeah.
What is the intercept going to be on that? 2. So what's your equation? Perfect. On the next equation, what appears to be the slope again? 1. And what's your intercept? And then lastly, perfect. Nice work. All you're having to do is walk backwards to figure out that your intercept would have been at 1. Okay? It's a matter of just identifying the slopes. And when we do this stuff on quizzes or when we have our test next week, I'll make sure that your graphs are a little bit cleaner than what showed up on the smartboard here. But I'll make sure that the lines are real nice and even so you can identify slopes rather easily. I don't think I'm going to be that mean and cruel to you to put a curve on there that you'd have to write the equation for. That's just kind of extra tricky. So I'll probably just keep everything linear. But why don't you try the next two real fast, and we'll check them in a minute. That last one's going to throw you for a loop. All right, let's see where we're at. So in this problem here, how many graphs do you see? 3 of them. So that means I have to have 3 separate equations, which means I have 3 changes in direction. So I start out with my Jay Leno. It's creepy.
Where
There were many, many, many days of college preparatory math classes that your mind just keeps going, I'll draw brackets.
What?
Exactly. So we know that there's three things going on, and they all happen around, well, the first one happens at -2, +2. I know that the first graph is dealing with everything that is smaller than -2. Remember, as you're reading from left to right, you are approaching -2. The minute you hit -2, you change graphs. So for your first equation, it's going to be x is less than -2. Okay? You're approaching 2, but as soon as you become 2, you're on the horizontal line. You're on that horizontal line between -2 and +2. Now, I know that I have to come up. As soon as I hit -2, I change lines. That's why it's a less than or equal to. The moment you become -2, you're on the horizontal line. The moment you become +2, you change to the negative slope. So I approach +2, I don't get there, but the minute I get to +2, I switch to the third line. So remember, usually speaking, if you're reading from left to right, as you come up and you don't have a dot there, the first graph will be a less than. The next one is a less than or equal to, and then so on. The first one should be open, the next one will be the solid, open, solid. It usually alternates through like that, unless you see dots telling you otherwise. Now the rest of this is just a matter of walking slopes and trying to identify your slope-intercept. So as I'm walking through on this one, I think we had a slope, oops, I think it was 3 if I'm not mistaken, right?
Yeah.
So my slope is 3, so I know it's 3x plus, how much? 10? Yeah. You'll have to walk it up a couple times on this graph paper, but for the most part, you should have been able to figure that out with too much of a hassle. The next one is plain old boring 1, 2, 3, 4 for the plateau. And then the other one has the negative slope of -3x, and I believe it also had the exact same intercept of 10. We do all right on that? Good. All right. And then the last function is called something different. We got 10.
Not 10, we got it at 01.
It's close enough. This last one is called a step function. Do you think you can figure out why it's called a step function? Because it looks like steps.
I don't like it. It's interesting.
And yeah, it's called a step function because all the values are just y equals a number. They're just horizontal lines going on up. So as you're reading this one, you know you have 3 of them.
Like, how can you tell, which way the things are gonna point when there's no like slope?
When there's no x.
No, like I don't. When it's pointing down like this, it's pointing down like this. You said it goes like this, but when like it's just straight, I don't know which way it goes.
Oh, I'll explain that here. When you're looking at values like this when it's horizontal, do you agree that this is a solid dot at 0? Okay. So I know I have a solid dot at 0. And I'm looking at numbers that are larger than 0, but smaller than 2. So I'm looking for numbers that are larger than 0, but smaller than 2. It's usually when you're reading them like this, whenever you have stub functions, it's normally going to be a less than or equal to, because you're going that direction. Unless it's going the other way, sometimes it could be flipped around. Just follow where the first one you read, just put it first, and you know that the values are between them. So if you just think, is 0 smaller than 1, but 1 is smaller than 2? And if you say that whatever values it might be, and you check it, you might catch it and flip one of them the wrong way. All right. And the same thing for the next one, it's between 2 and 4. And then it's 4 and 6. And our numbers are just 1, 3, and 5. Okay? Here's what I want you to do tonight. You should still have graph paper, right? Yeah. Okay. What I want you to do tonight are these handful of problems. There are 2 problems that give you a y-intercept that you have to graph the piecewise stuff. They give you y-intercepts that are like 13 and 16. Just make them both 10 or negative 10. I think one of them was negative 13, the other one was like positive 12. Just make it so it fits on that grid, the graph paper I gave you guys. The last couple of problems are writing of the equations. All you really need is just one sheet of that graph paper I gave you. If you need more graph paper, I'll put some up on the desk here, so when you guys are leaving, just grab an extra sheet. But we'll check these tomorrow, and we'll go into graphing and shading inequalities tomorrow. Extra questions at all? All right. Don't forget, the book is all online. The PDF files are all there, so it shouldn't be so bad. If you need to remember, this is section 2.7, so that's how I have them labeled on the website. Okay? Good work with this stuff, guys. This is tricky sometimes.